Hello and welcome to the Omnex webinar, Motivation for AS9145, APQP, and PPAP with a defense industry focus. Today's presentation is being conducted by William Ireland. William Ireland is an Omnex consultant that works across multiple industry standards and industries including medical, aerospace, automotive, and defense. Mr. Ireland is currently participating in the revision to the Defense Manufacturing Handbook, Revision A to B, to include the benefits of AS9145, APQP, and PPAP. He is currently a member of the AS9145 committee, intending to develop a handbook for aerospace, defense, and NASA. During this webinar, if you have any questions for William, please enter them in the Q&A box. You will get to them to the best of his ability at the end of the webinar. It does look like he's having some issues joining with his internet connection, so we may be delayed a minute. This webinar is being recorded, and someone from Omnex will reach out to you after the webinar. Please wait for emails from Omnex with how to access the recording and the slides. And we're going to pause right here while we wait for William to get back online. Hello, everyone. I see there's some questions. We're having some technical difficulties with the instructor's Wi-Fi, so we are waiting for him to rejoin, and the webinar will start promptly.
Well, I've
Great. It
made
looks
it.
like William is connected. Great. All right. All you need to do is share your slides, and we're ready to go.
All right, thank you for the introductions.
Oh.
All right, this is William Ireland. I'm coming to you from Phoenix, Arizona. I'm at the Lean Six Sigma conference, and wherever we may have all come from, I thank you for joining this webinar. There's some slides in here that are pretty rich in data and content, and advance the art of advanced quality planning intended for the defense industry. It's applicable to everyone else too, and it's been enjoyed by many industries to give quantum leaps and better quality, in the defense industrial base is kind of behind with regard to this. But I'd like to open up with 3 stories. So the first one, we're talking about motivation, like the reason why. What would motivate us to do something different? And so the first story is about Magnum PI. So we all know Tom Selleck, and he lived in Lake City, Michigan, and there were some tennis courts across the street from him, and I don't think he lives there now, but he did at the time. And I'm playing tennis with my family, and it's the 4th of July, and overhead, they do flybys, and maybe many of us have seen these flybys or at sports events, and they're kind of touching, and they were particular that day. So we stopped playing tennis and we watched these A-10 warthogs fly overhead, 2 of them, and we just stopped playing tennis, and for whatever reason, this is in 2008. And my wife and I were just kind of like crying, and was like, why are we crying? And why is there such a sensitivity here to like the American flag and so on? And so it was kind of the foreshadowing of both of us changing our job locations where we were in Michigan and in the automotive industry, and moving to a Navy base and working for the Navy, and myself as a manufacturing expert, and my wife in finance, managing large programs, money from the government side. And what was fascinating with this is being able to develop this motivation where, for both of us, we'd rather have a sailor come home than a flag, and we wanted to learn and help and motivate a higher quality sense out of the development of systems, that if our sons or daughters are using equipment that's been manufactured, we want it to be the best it can be. And so then that's my motivation. That's what we were doing. And for more than a decade, I had been a subject matter expert in manufacturing, having about 30 years of experience in the automotive and aerospace industry. And so the second story is about General Milley. So recently, he's in a meeting because there was, and this is like a recall for the auto industry. It's when the fleet grounds equipment and you can't fly, F-18s or helicopters, and so some problem happens, and some of the best corrective action activity takes place around these problems because it has a lot of attention you don't want. And so there's a particular part in a helicopter that had failed and grounded the helicopters of interest. And there's a high level meeting. Why did this happen? And the answer was, well, a lower tier supplier changed their process and didn't tell anybody. and it weakened the part in a way that it's failed, and it's got to solve this. He says, so why didn't they tell us that they changed their process? And the answer was, we didn't require it. So those familiar with advanced quality planning and production part approval processes, that's a fundamental thing, is that, to be notified of changes, because they can make a difference. And in this case, it grounded the helicopters. And the reason was they didn't have a procedure or a policy or a requirement in place to notify. So there was no one to get mad at but themselves. And my third story is Mean Gene. And he may not be mean, he might just be persistent. So the Gene in this case is Gene Dodaro. Gene Dodaro is the director of the Government Accounting Office. And he writes a report every year to Congress to tell them how weapon systems are doing. And for more than 15 years, more than a decade, almost 2 decades, he kind of comes up with the same responses from the 100 programs. Very few, if any, understand how to be ready for manufacturing after milestone C. And milestone C is that gateway where you start production. You demonstrated the product, but as a science project, let's say, but you may not have demonstrated with knowledge the readiness of a manufacturing plan. And so to that end, I had the opportunity to go to the Naval Postgraduate School. And I did a thesis, and you'll see the reference. If nothing else, get the reference and look it up and download the thesis, take a look at it in your areas of interest. And I think you'll find quite a story about the importance that I'm going to try to demonstrate with these hopefully compelling slides. So Gene Dodaro has been a trooper at saying one thing: look to industry to improve acquisition and reform it. Be more disciplined in 3 areas, and we'll look at those 3 areas. All right, so an important thing here is our approach to kind of doing the right thing. How do we improve? How do we keep making things better? And in 2004, Gardner authored a book and kind of discussed, you need, if you're going to do continuous improvement, you have to do it on purpose. You have to want to do that. It just isn't going to happen on its own. And a lot of times in the defense industry, we'll have things we call lessons learned. And it kind of gets a little jumbled, not too formal. But organizationally, as a contractor, you have an opportunity to look at these things. Today, in this conference that I'm at here on Lean Six Sigma continuous improvement, and oh, by the way, AS9145 has a whole chapter dedicated to improvement. And so gathering an evidence or an approach to this is important. So I like starting with this slide. It's a good benchmark. And here we have my thesis reference there that you can download. All right, so this data that I'm showing here is should be motivation enough also for trying to say, what can we do different to realize the design intent reliability, or the design intent durability of products that we put in the field to defend our country. And the cost of quality for all these tiers of manufacturing environment is excessive if you wait till you have a problem and you don't focus on prevention. And what does that mean in the preventive tasks? That's the development process, where you do focus on the not just the design, but the design of the manufacturing system, and acquire the appropriate knowledge to know you're ready to produce. And there's a weakness there, and the weakness is represented in this data. 75% of systems according to the Defense Science Board. And this chart kind of repeats itself. It doesn't change much, even though it was 2008 in this case. Is that they don't meet the reliability goals. That's the performance side. And here on this other chart, there's a database that's called the Red Stripe database. And it's every time that the Navy and NavAir in particular grounds the fleet and readiness is suffering. And 34% of the time, it's due to manufacturing and quality issues. And it's some of the best corrective action material you'll ever read if you get an opportunity, if this is a familiar area to you. And it's how do we, instead of looking at these corrective action things, how do we move it left to shrink these pieces of the pie? And this is just by percent, so it's not too revealing. And it shows where there's area of interest that is needed. And we will focus on the manufacturing and quality side. All right, so this is a graphic. I like a graphic position. It's kind of discussed in words. They're called knowledge gaps. The one that's called instability, but it's in a three area domains that's looked at: technology, and is the government ready to develop? Is there something we can do to get a material capability, and is the technology ready? How do we assess that? And so there's gateways in product development, and this one's called the PDR, means preliminary design review, and it's associated with what's called milestone B. And it says it lacks maturity. And one way they measure maturity is to look at the amount of drawings that are complete at the milestone. And often we say, is it designed right? We use those words with PDR. And at CDR, which is a little later in the development and design process, that's critical design review. We'll call that just design. And in critical design review, we want to have 90% of drawings, let's say, as a measurement to say that we have some level of maturity to continue development. But maybe they're not that mature, and there's an instability in design change, or maybe there's scope creep in requirements, and it throws things back. But there's a lot of activity pumped into these two areas to try to improve. If you look at the research, there's a lot done to say, let's put PDR before milestone B, and let's have a second one after milestone B. And we'll call that a knowledge point 1. So we'll use that term a couple times. Knowledge point 2. And this comes out of the GAO reports that years and years and years of publishing. They look at these things called knowledge points. Knowledge point 2 is the weakness with respect to the design not being mature. And maybe it's the first time technologies are being integrated, and any particular technology was fine that makes you fly faster, see better, be more durable, give you different insights that you want a system to have: radar, it's aerodynamics, it's impulse, if it's a missile system. All those technologies are sometimes looked at quite in a stovepipe, and they enter this, hey, we can solve a problem, be more ready to counter threats that are perceived and looked at. And so when integrated, there's a second maturity level that can we integrate these things? Maybe it's software and being in the net. We call the high level ones KPPs, and those are metrics that say, if you can't get this performance, then we don't have a program. And then you have the lower level ones, KSAs, which is another layer of requirements of performance. And then there's another thing that to look at, which is technical performance measures. And there's a family of requirements. Functional is the important part to take away from these first two. And they do a great job of qualification, right? We make parts, we make systems, we test them, and then we say, oh, since you could fabricate it, here's the assumption that's being made. If we can fabricate it and make something pass a functional test, call it qual, then we say, well, we must be able to manufacture it. And since 1996 in the Perry Memo, that kind of disbanded all manufacturing knowledge out of DoD. They were excised out in 96. Standards were reduced, and those capabilities of understanding were then said, we want consensus standards, and we want them not military standards, so you don't have the $1,200 toilet seat or something. We want to have consensus standards that then will follow, and so the standards industry increased, and out of that was born things like aerospace standard 9100 and or the ISO standards, and they became the approach to things. But still, systems engineering and the DoD acquisition process said, we're just going to leave it to the manufacturers who know best. And they lost the insight into manufacturing capability in the DoD oversight that they do contractors. And so at milestone C, there's the issue that we have poor production outcomes that could come from any of these three areas of weakness. And the largest one that has the least amount of attention in any literature or review or implementation or standards is this area of manufacturing and having poor outcomes. It's just not mature. It's not data driven. It's a risk evaluated system. So in my thesis, I decided to look at these three areas and focus on what's called knowledge point 3. And you'll hear these terms if you're involved in contracts and in the product development cycle. You may hear these KP 1, 2, and 3, and they're metrics on how you look at the success of a program, trying to come up with metrics. And I focused on what makes the right approach to milestone C, a goal where you can start production with some know-how. And my findings through working with at least 5 major defense primes and with over 100 suppliers doing manufacturing readiness assessments, there was no eye on advanced quality planning or knowledge of the development of the production process. And we call that development cycle EMD, engineering and manufacturing development. But I challenge anyone, and you can email me back or try to reach back to me, is it the rule or is it the rarity that manufacturing development has knowledge that they can make more than 2 in a row or run at rate and meet requirements? Because we've created an environment where we don't know how to manufacture because it's not required. It's not required to know if you can manufacturing at rate. And therefore we don't know, and we call it LRIP, low rate initial production, but we don't pay attention to these objectives that are here on this chart too closely. You know, we have a quality system, and that's the AS9100, and we're going to look at some compelling data and the key to the research on what works best, what's the right thing, does it apply to the DoD, and why is it there, what are the objections, and how can we overcome that? And what's on the horizon is the aerospace industry adopting the automotive industry approach to quality enhancement and trying to make changes when the needs are just a little bit different or the quantities are different. And rather than objections to doing this, it's how do you end up with a better approach to knowledge at KP3. A little chart here on what is KP3 according to the GAO. And today, the criterion that the GAO is looking for when they measure your program, if you're high enough on the food chain of product development, you will notice that the GAO is assessing a product, or maybe your products are inside of the larger equipment that's being evaluated. But the GAO is looking for what they call manufacturing readiness level 9, which is equivalent to saying that they're using the aerospace standard 9145, and they have the knowledge that's generated through deliverables that are part of the PPAP process. A little more discussion from the GAO and what they say, this knowledge point 3, can you be ready? You have statistical evidence, and do you have an ability to demonstrate that you're hitting tolerances? Is the margin big? Are you looking at, variability in some way? And I found universally that it was very difficult to come up with. We all are familiar with first article inspections, and we rely upon that almost exclusively. But that's AS9102. AS9103 is saying control plan. What should be the definition in your production process where you're taking data and looking at variability that's significant, such that if you're outside of the requirements of the variability of a particular critical characteristic, then it might affect the technical performance measures, or the KSAs, or the KPPs, and threaten the threshold of the success of the intended equipment. All right, so there's something going on here. This is 2 different scorecards that you'll find in the GAO annual reports, and these are just cut and paste. And so in 2013, when I started doing my thesis, and I spent quite a bit of time doing it, because they let you kind of, you're working and you're doing your thesis, and it was a very interesting experience. And so I looked at these criteria that were here, and let's look at manufacturing. That's KP3. So you can see the blue bars, they represent KP1, KP2, and KP3, and KP3 is again our focus. So are you demonstrating critical processes that are in control? That's AS9103. But what are those critical processes? What are those things? And if you define these critical or key characteristics, then you have to take data, and there's a lot of resistance to looking at emerging risk in manufacturing from a planning point of view or from an execution point of view. And yet you need to have that control. And then in 2013 to 2017, you can notice that they've changed it. Demonstrate manufacturing readiness level of at least 9, where critical processes are in statistical control. So there's a lot of similarity to those metrics. And you can see in both cases, for the system that's being looked at here, a particular system, that the attainment of product knowledge for manufacturing is unsatisfied with regards to this bullet that I've described. And neither is it planned. Now, that change, that criteria change that we're looking at may look minor, but it isn't, because it's really saying you ought to follow AS9145. It's kind of between the lines, because I sent my thesis to Mean Jean Dodaro, the GAO lead director, and I sent him my thesis, and they changed their criteria to represent what I was writing about. So I take some credit, whether this is good or bad is to be seen, but to influence how they're measuring systems today. All right, so simply put, I'm on the committee to look at aerospace standards in particular for the department, and I looked at these things as being unfriendly in the AS9145, its current version and release, which was in 2016 when it was released. So it's in review. 2022-23, there's a change. We'll look at what the changes are in small and the impact. But I rewrote this and submitted to the committee. I'm working with the DCMA, and they want this in all contracts, space and defense, and so we're working together to do that. We're going to be at the committee in March of this year to suggest that some of these changes about prevention or moving things left on this approach to getting knowledge for manufacturing and production readiness under more robustness of how to, more prescriptive, which has kind of been shied away from. And we have the AS9145, and then we have the AS13145. I don't know if it's released yet, but it's the same thing. It's what do we want to do for advanced quality planning and production part approval process, kind of a missing link that all other industries do and the defense does not. And that's what we're trying to move towards, or at least a certain community of us, to try to have more knowledge at production readiness. So here's an actual example from a 2022 GAO report. And I'll just direct attention to the right side where it says demonstrate manufacturing readiness at level 9. And you can see that it's not intended, it's not planned. And so it's like a failing scorecard. And what we want is to have this knowledge point 3, the desired realization of MRL 9. And what would that look like? What would it take to do? Is that a cost add or is it a cost reduction? So according to the Air Force, the head of manufacturing, it's the G23 committee. It's David Carr. He is the chairman for that committee, and his committee delivers the AS6500 standard for manufacturing planning, and it has a lot of these best practices in it. APQP really is just best practices that are found in this document produced by the Air Force called Handbook 896. And it's in revision right now. And to follow more closely the AS6500 standard to the 896, and it's kind of married to the APQP as well. And so we can see that there's this amounting effort. And if you look at the top 5 prime contractors, and maybe you're part of them, they're hiring directors of APQP and PPAP. And so that's a need. And I think soon the MRL's manufacturing readiness levels will be mapped into the deliverables of the APQP and having a production readiness. So I think that's the direction we're all going. Yesterday, I was in a meeting with Crane here conference, and they're already doing PPAP and APQP as a standard. And of course, Omnex trains on those things, and I brought the defense side of things. All right. Sorry about that. All right, so basically all the industries do this except the DoD, and we'll take a look at some of the numbers and what that means. So I studied this industries: aerospace, automotive, medical, and DoD, and I looked at just the 3 largest contractors, which are readily these data are available, and how many employees are involved, the scale of revenue, and in some cases there was export, and I didn't have data for export from these industries. And I go, okay, so they're scalable. All those things are a lot of people and a lot of effort. And then I looked at something, and I'm going to try to parse this into 2 pieces, right? So the top one is before there was AS9100, and before, there was ISO 9000, 9001, and then the automobile industry called it QS 9000. And there was an organization, AIAG, and the ASQ, that did a survey 10 years after the introduction of this standard. The significance of this standard is essentially saying APQP. It's essentially AS9145. And it said, did quality improve? They're asking, 800 companies or 1,100 companies in the ISO. Who followed ISO and who followed the more prescriptive QS9000 approach to things? And the QS9000 or prescriptive approach showed the supply chain had a dramatic improvement in quality and in reliability. In the ISO group, it was hard to find that anybody said ISO helped us, but we had to be ISO in order to play. And in that, so McGraw-Hill carried out that investigation. The ASQ and the AIAG carried out the other investigation. And statistically, I put together a chart to say, is there a benefit to following one or the other, and why? And the numbers are the why. The improvement was 50% of the time there was an improvement, and 6% of the time there was an improvement. Oh, well, really, it was 50% of the time there was at least 50% improvement. I mean, it was just dramatic if you followed the prescriptive approach, something more like APQP. All right, so the QS9000 morphed into something that was called ISO TS Technical Spec 16949. It's actually in the CFR, the regulations for doing contracting, and this is the TS spec. The 16949 is actually in there for a higher level quality standard that one could follow, but nobody ever assigned that one. They really, I'm going back in time because it's level D for AS9100 here, but level C had these things when I did my thesis, that they had a customer specific clause, and you could assign APQP guidelines. You could assign PPAP requirements as a higher quality standard for contracts that had more complexity, and you could have statistical requirements put in here, but they didn't. They just were happy to have AS9100 compliance put in a contract for DoD. But really, to dig further and you want the benefit, if you want higher quality, it's this more prescriptive approach. And AS9145 is bringing that to the front. So I have a graphic here, and I'm gonna go back and forth between the two. But this is the product development cycle in the defense industry. Technical readiness on the one hand, and manufacturing readiness on the other hand. And the technical readiness has laws associated if you're an ACAT-1 program, and that you must be at least a TRL 6 to enter in manufacturing, engineering and manufacturing development. And I take a look at this, and this is what I'll call the current state. Where we're going is this change here. Now I'm going back and forth on the slide to kind of show what's changing. And the red is that we should apply APQP and PPAP for component qualification and system qualification. We should add the production, essentially having a production qualification. And then when you're really ready to launch, you have some data and you have a PPAP, which is a warrant statement. And I have a white paper that I've done on what is the procedure for having a warrant, a statement for when you do things, because there's 3 areas that happens. It's a different topic, but it's how do you say that I'm ready to produce, and you have a handshake process and deliverables that show you're ready. All right, so this kind of brings us down to the end a little bit here, and we'll let next couple slides where there's insights for the government how to improve. So if you're an agency, the Army, the Air Force, the Navy, and you're OSD, and you're trying to do contracts for defense, clearly state requirements. You can have SD15 is a systems engineering requirements definition document. You can Google it at SD15, and you can show that can you make specifications for manufacturing. And even though they kind of like don't do it, you can do it, but I don't fund them. And so could we write clear requirements for manufacturing readiness? Can we have a DID, a data item description, and a seadrill defined? And so I'm defining a family of them that we're going to put into the ASSIST database, which you may be familiar with, where contracts can pull these DIDs into the contract that will follow AS9103 or AS6500 already has one in there, which is manufacturing plan. These are the knowledge gateways. AS9145 is the one I'm developing with DCMA, and then we're going to try to put that into, make it available as the data item description. So it kind of gives you the how-to, the content, the format, the sequence, the time to make these deliverables more objective and prescriptive. I think there's a role for incentive contracting because there's a lot of objections sometimes. And this is one of those things that you could call behaviors. And let's say I put $30 million as an incentive. If you get your supply chain to comply with APQP and PPAP, let's say, and you get that $30 million, you know, and maybe we do this over a period of 3 years, and then it becomes normal. You know, how do we make the change? So we have the motivation because there's a problem. 34% of the problems that ground the fleet are manufacturing related. We want to move that in the right direction. Maybe it's incentive contracting will help us get there, to get these this transition to doing this. Now, I know from doing this in the automobile industry, and yes, there's lots of quantities, but not always. And so when we did these launches for PPAP, and you know, we did experience a dramatic improvement in quality. And I did that in 3 countries, and I think I had 4 states, and doing PPAP. And what I found is I could review 100 suppliers like within a week based on the deliverables in APQP and PPAP, the deliverables. And then when I did this with MRLs in the defense industry, it was all over the map all the time. It really wasn't a very strong index, and it didn't require knowledge, really. Just we invented some maturity points, and all agreed that things were like, you know, fit the criteria of 400. I think there's 600 questions now in the MRA assessment process, and they've added cyber now to some of that. And I think that's good. But still, those questions don't always lead to a knowledge base, a KP3. And that's the direction it should go. And the standardization to the MRL 9 is just emphasizing that. And then having a product or a tool or software that we can do our digital transformation to have robustness in acquisition of all phases, including manufacturing, is something that we want to provide clients. You know, how do you have contractor strategies to improve production outcomes? And so there's a little list here. And can you, if you're doing APQP, you have an advantage to get business for you know, for upcoming competitions for new material. And I think you can. I think you can present yourself in the different sections of a contract where you're not just looking at cars and failures from the past to say, hey, I'm a good company. You probably are a great company, but it's how do we have an edge? And if you're doing this APQP, and so like Boeing and Raytheon are all hiring APQP directors, I suspect there'll be managers and workers on this too. So I think they see it's coming. These are just the phases in the APQP phases. So I say 2022 because it's not released. I thought it'd be released by now, but these are some of the goals that how they state them by phase. And this is showing that in 2016, which is the current APQP 11 elements, they're deleting the word records in the current one. You know, it used to say records, and in the current one that's pending, they use the word documentation instead. The red word, it's very small changes, but maybe significant. And they've added FMEA or production control plan, not just control plan. But really that's AS9145 or more enhanced, and it shows how this future one that's anticipated will be coming out. The status of things, and we can open up to questions if there's any, is there's changes taking place now in each of these standards, these consensus standards. They, I think, are all going in the right direction. I think they do need to be more prescriptive, especially the engine community is really dynamic, and they have the AS13000 series. And some of the, it's just more prescriptive. They're bringing a lot to the party, and I like their enthusiasm, but I don't like the proliferation of standards for APQP and PPAP. All right, so I think then, kind of coming full circle, we have training that we want to do. I think Miles may have talked about that in these different areas, and the courses that we offer and consulting. And I hope that this was an informative seminar for you. It's directionally someplace we're going. There's a lot of facets to this to make it the best it can be for you. And if your company is looking at this, we hope we can help you. All right. Appreciate it. Thank you for your time. So if there's no questions, and I hope you had a good lunch, and look to Omnex to help you out. I appreciate that.
Thank you, everyone.